Alright, so for example 6, we're going to solve that cosine of 2x is equal to 1/2 for all x between 0 and 2 pi. So let's think about this first as if I was just looking for cosine of x, because that's what we've done before. So if I wanted to know where cosine of x was equal to 1/2 between 0 and 2 pi, remember we had defined our angle there, so we wanted to solve for x in this case. So we were looking for where cosine first is going to be positive. Where's cosine positive at? Quadrants 1 and 4. So I'm going to have two answers here. One of them is quadrant 1. One of them is quadrant 4. No, I didn't mean to put the 2. Right now I'm doing it just like what we've done before, okay? And then I'm going to build on it from there. Alright, so where is cosine x or y? It's my x value. So in quadrant 1, what angle in radians, because we're going from 0 to 2 pi, so what angle has an x value that's 1/2? Okay. And in quadrant 4, what angle has an x value that's 1/2? Alright, and so if this problem had just been cosine of x, those would have been my two answers and we'd be done, right? But what's the difference between our problem that I wrote down there and what we actually had? Yeah, it was a 2x and not an x. So what we're going to do here is we're going to say that 2x then is going to be equal to pi over 3. And we're going to have to do a little work, so just go with me for right now. So we're going to put plus, what is the period of cosine? Do you remember? 2 pi? 2 pi over b, when this, so it's just 2 pi, okay? So plus 2 pi and then n, where n has to be an integer, an element of the integers. So then quadrant 4, again, instead of x, we're going to have 2x. It's going to equal the 5 pi over 3 plus 2 pi n. So we put that plus 2 pi in there right now because there could be some, I call them hidden angles, okay, that we don't know about yet. So we're going to use that plus 2 pi n to help us, and at the end it's going to go away.
What is
N is an element of the integers. It's a whole number, basically, what we think of as whole numbers. It's the number of times we can go around the circle. Alright, so we need to solve for x. So to get x by itself, we're going to divide everything by 2. I'm going to have to do that on both of these equations because they were both 2x. And so let's simplify that. So we get x equals, dividing by 2 is the same as multiplying by what? So that's going to give us what? Pi over 6. And then plus pi n. Alright, so if we were looking for like the general solution or find all the solutions, we would be done. But we're not. They're specific. They said we only want from 0 up to but not including 2 pi. So in order to find them, we're going to create ourselves a table. And in this table, we're going to have our n in the first column. Doesn't have to be a very big column. It's just going to be a single number. In the second column, we're going to have our first x. So x will equal pi over 6 plus pi n. And in the third column, we'll have the second x. So x equals, in this case, 5 pi over 6 plus pi n. And now we're going to pick some n values and plug them in. Now I could pick negative n values, okay? But since we used the smallest x's we could find, we're not going to need to worry about that unless for some reason, and I can't recall ever seeing it, but unless for some reason my angle, like that 2x, maybe it had a negative in it. All right, so in that case, we may have to worry about negatives, but otherwise we're good. So let's start when n is 0. So we're going to plug in n is 0 into our first column. So we get x equals pi over 6 plus pi times 0. So that's pi over 6 plus, what is pi times 0? And what is pi over 6 plus 0? And then ask yourself, is pi over 6 in our domain? Is it between 0 and 2 pi? Yes, it is. So I'm going to box it. Then I'm going to plug in a 0 into our second equation over there in the third column. Then we're going to plug in n is 1. And so it gives us pi over 6 plus pi, which is? Good. And is that between 0 and 2 pi? So it's also an answer. Plug in n is 1 into the other equation. So we end up with 5 pi over 6 plus pi, which is?
11 pi over 6.
Good. Is that between 0 and 2 pi? Yes. 2 pi is 12 pi over 6, okay. And we're going to keep going. We're going to do this until we get one in each column that doesn't work. Once we find, once we find a value in the first column that doesn't work, I don't have to work in the first column anymore, okay? And when I find a value in the second column that doesn't work, I'm done in it.
Will this be the part where we need a stretch paper?
No. I mean, yeah, maybe. All right, so let's plug in. N is 2. I'm sorry, I know I'm at the very bottom of my page there. So it gives me pi over 6 plus 2 pi, which is 13 pi over 6. Is that between 0 and 2 pi? No, so I'm done in the first column. I just need to check my second column. Usually, once the first column doesn't work, the second doesn't either. Usually, okay? So we add them, and we get 17 pi over 6. Is that between 0 and 2 pi? No. So I can see my solutions are the ones that I boxed there.
13 pi over 6 in the first one?
And so I'm going to come up here to the top, and I'm going to list my answers. So I got x is equal to smallest to largest. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And so there's our solutions for this equation.